So now let's try to understand this very important term called independent events in probability. So I have two events A and B, right? I have two events A and B. Now these two are independent. These two are independent if happening of A does not influence happening of B or vice versa. So basically these two are, as the name suggests, they are independent of each other, right? So let's try to understand by taking a couple of examples that will help us understand this better. So if you have a coin, it has a head and a tail. If I toss it, I might get a head or a tail in the first turn. If I toss it up again, I might get a head or a tail in the second turn. Now, let me ask you, whatever you get in your first attempt is basically your A, right? That is the event of getting a head or a tail in the first attempt. B is the event of getting a head or a tail in the second attempt. Now, what you got in the second attempt, does it have to do anything with what you got in the first attempt, right? You might get a head here. You might once again get a head or a tail. You might get a tail here. You might once again get a head or a tail, right? What you get here is completely independent of what happened here, right? Once you get a value here, you can still get anything here. So such events where your B is independent of A, doesn't depend, they are called independent events, right? Likewise, you might have one more case where you have a bag which is filled with lots of colors. So for example, if it might have a couple of red balls and it might have a couple of blue balls and it might have a green ball, right? Now if I say my event A is getting a red ball, or basically event A is getting a ball, or rather red ball, in first attempt. So what is the probability of getting a red ball in first attempt? What is the probability of A? That is basically the favorable cases to A are 2, and the total number of cases are 1, 2, 3, 4, 5. There are 5 balls here, right? So 2 by 5. That's the probability of getting A. So for example, I got a red ball. For example, I've taken this red ball, I've picked it up, right, and I've kept it out of the box. Now if I say B is getting a red ball in second attempt. Now I would like to ask you, what is the probability of getting a red ball in second attempt? So it's the first red ball is out of the box now. Now obviously you have one favorable case, right, and you have 4 here. So the thing here is, this B is dependent on A. Why? Because this denominator reduced from 5 to 4 only because you got a red ball. For instance, in the first attempt, if you hadn't got this red ball, if you didn't get this red ball, and if you got a blue ball, right? If you got a blue ball and you kept it out, it wouldn't make a difference, right? Then the answer would be 2 by 4 and not 1 by 4, right? So this is without replacement. This case is called without replacement case. So you have taken a ball and not replaced it. But on the other hand, in my first attempt, for instance, if I got a red ball, but I kept that red ball back in this bag, right? Whatever it is, I kept it back. Then what is the probability of getting a red ball in the second attempt? It still remains the same, right? So you have 2 favorable cases divided by total number of cases, which are 5. Now I'm not saying that the probability of B should be same as A. So in both these cases, what we saw is probability of A and B. It gives us a feeling that independent events are those events in which probability of A and probability of B are the same. No, that's not the point here. The point here is, if I keep this red ball back, then it becomes a fresh case again, right? So it doesn't matter what happened before this. If I keep the ball back, then it comes back to the initial position, like wherever I started from. Then carrying out anything carrying out anything else, carrying out this particular event, it is not dependent on what happened before, because whatever had happened, I again kept the ball back, and it's back to square one. So what happens now is completely independent of what had happened. But on the other hand, if I did not replace this red ball, then things would change, right? Then, in fact, I would say if I don't replace the ball, then things would change, because then B's value would depend on whether I got a red ball in the first attempt or whether I got a blue ball in the first attempt, right? Or whether I got a green ball. So in that case, without replacement case, B would depend on A. But if I replace whatever I got and if I keep it back in the bag, then the two events are independent of each other. So I hope you have understood the difference of when two events are independent of each other. So kind of form an intuition. The intuition here is the conditions in which you started your experiment, if the conditions are restored, then the second event is carried out, then the first event and second event are independent of each other. But if your conditions change, then your first event and second event usually become dependent on each other. So this is what you understand by, so there's no basic formula, right? So this is the trick here. You don't have a formula to tell whether two events are independent or dependent on each other. That is your common sense. You have to use your common sense. You have to use your sense of logic. Only that will actually help you determine whether two events are independent of each other or they are dependent on each other. So I hope I was able to make sense of what independent events are. Let's now move on to compound and conditional probability.